in series and parallel. So let's start with a number of resistors. Um, start with a number of resistors that are in series. So if we have, let's say, three resistors R1, R2, and R3, we know that the total resistance is equal to the sum. Similarly, if we look at resistors in parallel, so we have, say, resistor R1, resistor R2, and resistors R3. The total resistance 1 over RT is equal to the sum of the reciprocals of the resistance 1 over R3 plus and so forth. Okay, so if we have only two resistance R1 and R2, so if we had only R1 and R2, then 1 over RT would be this would be equal to, so 1 over RT would be equal to 1 over R1 plus 1 over R2. If we simplify this, we get R1, R2, R1 plus R2. That means if you now flip this over, you get total resistance equals R1 times R2 divided by resistance 1 plus resistance 2. So this is for two resistors in parallel. Okay. Now that we know about resistors in series and parallel, let's find the equivalent resistor in a simple resistor network. For instance, here's an example. What we want to find is between nodes A and B, we want to find out between nodes A and B, what is the equivalent resistance RAB. Okay, so here, let's see. So let's start. So we have this resistor is in parallel to this resistor. This resistor is in series with this resistor. So now the resistors are in series. So let's add this plus this. So we get RT here of 5 plus 1, 6 kilo ohm here. And then up here we have 6 ohm, 6 kilo ohm and 3 kilo ohm resistors. So those are in parallel. So we have 6 times 3 divided by 6 plus 3. So which is 18 divided by 9 equals 2 kilo ohm. So we can replace this resistor network with a 2 kilo ohm resistor network, and we can replace this network with a 6 kilo ohm resistance. So let's do that. Okay, so we have done that. So we replace that. Now we have this 4 kilo ohm resistor in series with this 2 kilo ohm resistor. So what can we do? We can combine these two into one resistance, which is 1 4 kilo ohm plus 2 kilo ohm, which is equals to 6 kilo ohm. Okay, so that's what we have next. So that's what we've done here. Oops. So that's what we've done here. Now this 6 kilo ohm resistor and this 6 kilo ohm resistor share the same nodes on both sides, so they're in parallel. So since there are two 6 kilo ohm resistors in parallel, we can do 6 times 6 divided by 6 plus 6, which gives me 36 over 12 equals 3 kilo ohm. So we can replace this whole series resistor network with a total of 3 kilo ohm network. So that's what we've done next. So let's see. So we now have a 6 kilo ohm resistance, a 3 kilo ohm resistance, and a 3 kilo ohm resistance in series. So we have total resistance between nodes A and node B is equal to 6 plus 3 plus 3, which is equal to 12 kilo ohm. So RAB is equal to 12 kilo ohm. In other words, we can replace this and this with simple wire and make this a 12 kilo ohm resistance. So essentially what you have is between nodes A and B we have a 12 kilo ohm resistance. Okay. So one more example. So let's see, here is another simple resistor network, and we're again concerned with finding the resistance between nodes A and nodes B, so that's RAB. Okay, so for this, now let's take a look at, here, right here, between this node and this node. The 5 ohm resistance and the 20 ohm resistance share two common nodes on either end, so they're in parallel. So we have 20 times 5 divided by 20 plus 5, so that's 100 divided by 25, which is 4 ohm. So this resistor network can be replaced with a 4 ohm resistor network. So let's do that. So we'll do that now. So that's what we did. Okay. Now this 4 ohm resistor and this 1 ohm resistance are in series with each other. So between this node and this node, so they're in series right here. So these can be combined into 4 plus 1, which is 5 ohm resistance. That's what we have here. So we have a 5 ohm resistance. Now, if you look at it, this 5 ohm resistor shares a node between here and here. So does this 20 ohm resistor. So the 20 ohm resistor and the 5 ohm resistor are actually in parallel. So we have again 20 times 5 plus 20 plus 5, which is 100 over 25, which is 4 ohms. So instead of this resistor and this resistor, we can combine these two guys and put a 4 ohm resistor there. So that's what we have. We have a 4 ohm resistor right here. Then we have a 2 ohm resistor, 4 ohm resistor here. We can combine that to form a 6 ohm resistor because those are in series. Also, if you look at this resistor between node B and this point, there's an 18 ohm resistor and also a 9 ohm resistor. So actually this 18 ohm and 9 ohm are actually in parallel. So we have 18 times 9 divided by 18 plus 9, which is 18 times 9 over 27, 9336. So we have a 6 ohm resistor. So we can replace this with a 6 ohm resistor. Okay, so what we end up now is a 6 ohm resistor in parallel with 6 ohm resistor. So let's look at that. So we have the 6 ohm resistance and 6 ohm resistance, and again they share a common node on both sides, so they're in parallel. So since those are two 6 ohm resistance, we end up with 6 times 6 divided by 6 plus 6, which is 36 power 12, which is 3. So this can be replaced with simply a 3 ohm resistor. So this is what we have. So we have a 3 ohm resistor in series with the 8 ohm resistance between node A and B. So we can add 8 plus 3, so that's 8 plus 3, 11 ohm. So what we have is node A, node B, and an 11 ohm resistor. So RAB equals 11 ohm. Okay. So this is some simple example about equivalent resistance.